Welcome to Filtration Matters, the regular podcast from BOFA International, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and system design are helping to improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts talk about how advances in extraction technology are helping to optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Today, I'm delighted to be joined by Luke Ziolkowski, an international business development manager at BOFA with specialist knowledge of the 3D printing and additive manufacturing environment. Luke will be taking us through some interesting structural changes currently happening in this area in terms of technology, material science, and supply chains. We'll also take a dive into the world of filtration to understand the challenges facing 3D printing and how BOFA technology is keeping pace in this fast-moving sector. So welcome, Luke.
Hi, Phil.
So this sounds like a fascinating topic of conversation, but before we go any further, it'd be great to find out a little more about your role at BOFA and your specialist knowledge in additive manufacturing.
Right, Phil. So I've been at BOFA for about 5 years, and I specialize in additive manufacturing and 3D printing in a way where I'm in contact with printer manufacturers, material manufacturers, and end users. And my job is to help them find solutions to what these processes give off during the printing. So I spent the past 5 years learning and applying the details I learn about these processes to the products that we can offer to the printer manufacturers.
Thanks, Luke. So perhaps we can start by talking about the recent evolution of 3D printing. We know it's been around for about 60 years, but it seems only relatively recently that we've come to think about the technology beyond prototyping and customization. What's been the development cycle?
So as you said, 3D printing started in a garage, and in some cases it's still there. But in all the years of development, we have seen a shift from hobbyist and prototype use cases to functional and production level parts. So we're seeing a great growth in professional use of 3D printing across many industries, with aim to use additive manufacturing as a functional part production process. So from fan blades and turbine engines to metal and plastic vehicle components or spare part production on ships at sea, we are seeing more 3D printed parts and products around the world.
Okay, so before we dive deeper into the topic, I guess now might be a good time to explain the difference between 3D printing and additive manufacturing.
So if you Google 3D printing, you'll get millions of hits. If you Google additive manufacturing, you'll get less. But the terms are and have been pretty interchangeable so far. However, the industry has recently led us to understand 3D printing as the hardware itself, and additive manufacturing being the process for functional part production. So for our purposes, if I say 3D printing, I mean the 3D printer. And when I say additive manufacturing, I'm imagining a production line for finished goods and functional parts.
So what's enabling this shift to a mass production environment using 3D printing?
So there are three principal drivers for the growing investment in additive manufacturing. Firstly, advances in the speed of 3D print systems, which is making companies look closely at the cost breakpoints for mass printing products and making them reassess the traditional mold tooling process. In some cases, if the cost per part still suggests the standard mold tooling approach, companies have found that the fractional cost and lead time of 3D printed tooling allows them to have a quicker turnaround for standard part production, giving them flexibility to change part structure without the cost and time consequence of standard tooling processes. Secondly, materials science. So development of functional materials that are purpose designed for specific product requirements, such as tensile strength, fire, or scratch resistance. These materials can make mass production a more cost-effective option. You can see some examples of this with Additive producing a 3D printed shoe, or bicycle manufacturers finding ways to reduce weight and add customization to their professional offerings. Thirdly, supply chain issues. So concerns exist over much publicized parts delays from overseas suppliers who have limited local production capabilities. So to overcome this challenge, more manufacturers are turning to additive manufacturing to help assure parts security through more local on-demand production.
Okay, so I guess maybe now will be a good time to explain how BOFA technology is helping to enable this changing additive manufacturing environment. Why should manufacturers invest in filtration systems?
In simple terms, our extraction technology is core to productivity because systems designed and produced by BOFA help maintain a clean working environment for operators and keep equipment free from process emissions.
So maybe we take that first point, maintaining a clean operating environment. Tell me what this means.
So a clean operating environment in this case means we want to take care of the operator's quality of life and health. 3D print processes emit gases and particles. Smelly gases are the easiest to notice, and they mostly affect quality of life. But there are other gases that are invisible and lack a smell, and that could be a health concern. There are also ultrafine particles that are hard to detect for a human, but may be harmful to your health. All of this risky fume needs to be filtered out. The mix of gases and particles varies by process, but BOFA extractors are designed to handle the full spectrum of fume from these processes.
So what's the productivity benefit of BOFA fume and particle extraction?
So poor filtration of a 3D print process can cause quality issues with the print itself, or it can affect print hardware. All materials give off a mix of gases and particles due to the nature of the process. You're heating up a polymer, for example. Some materials will give off emissions that could be detrimental to the finished product quality. For example, some new functional materials such as PEEK can create a mist that can settle on the hardware and the printed object. Extracting these emissions helps keep the print chamber clean and maintain the integrity of the finished product. And depending on the temperature setting for the print chamber, you can connect the BOFA filtration system to extract and filter the air out of the chamber, or you can create an airflow loop, cleaning the air, but helping maintain the chamber temperature without wasting energy.
Aside from atmosphere management inside and outside the print chamber, are there any other benefits to additive manufacturing processes of BOFA technology?
On the surface, BOFA systems have a 3-stage filtration capability. We pre-filter larger particles such as dust, then we filter ultrafine particles via the HEPA filter, and finally we absorb gases into our advanced activated carbon filter. But if you dig deeper, temperature control is critical within the print chamber. Chamber temperature control is essential because 3D printers operate in a narrow temperature envelope from the bed up to ensure that feed material reaches the critical point where it can be layered and bonded. So getting this relationship right between maintaining a precise operating temperature and achieving effective filtration is critical in optimizing the value of new generation functional materials. Increasingly, the trend is towards higher and higher temperatures to deliver their functional benefits. So achieving both temperature control and filtration performance is essential, and this is what BOFA specializes in. For BOFA, this means ensuring that the process of recirculating chamber air to extract emissions is achieved without detriment to the required operating conditions. That's why innovations such as BOFA's 3D Print Pro HD, or hot temp system, incorporate airflow innovations that actively help maintain optimal temperature conditions during 3D print operations. At the end of the process, the extraction system also runs a purge cycle that helps cool the chamber progressively and methodically while passing the air through a carbon filter to help remove any VOCs, or volatile organic compounds, known as gases, that continue to be released.
And finally, Luke, how do you think additive manufacturing will evolve in the years to come?
Yes, Phil. So there is a trend towards more local production, which is enabled by 3D printing. Current geopolitical uncertainties are likely to encourage greater investment in localized capability, giving companies a greater flexibility to serve their customers. So also greater process automation and integration of manufacturing processes will become ever more important as additive manufacturing scales to production levels. And here at BOFA, we are at the leading edge of extraction innovation through our IQ platform.
Thanks, Luke. Many thanks for your insights into the world of additive manufacturing. It's a fast-moving environment. I think we can see that. And it's an environment where innovation is delivering value at each stage of the process. And of course, that includes emissions extraction.
Yes, thanks, Phil. It was a pleasure talking to you and to everybody. Thanks for listening.
If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.